Good morning. We're going to show how Logscope can import and display very quickly time-based data. So we have the the drilling parameters here, and we have the time las here, which has the drilling data in it, and we have the time to depth relationship stored in this file here. So let's load this one. And when you double click, it will load Logscope. The depth-based log that we're going to use will be the bdepth. There are multiple depth logs, and it may take a bit of trial and error to find out which is the correct log to load. So we're going to load this data here, and Logscope displays the sample rate in depth and as per the time record along the bottom. And we could move these red bars to say, well, we're only interested in this section here where we have a high data density. Now we need to specify the sample rate. I'm going to use 0.5 feet, but you can choose a sample rate that you're comfortable with. And it loads the data like so. The next step is we need to add in the time-based data, because that has the azimuth and deviation. So we tap on merge and we select well, and we can select any well in the list, or if we hit the plus button we can actually grab the time data which is there, and it will come back and it will say it wants a depth log, and because it knows that it doesn't have a depth log, it's asking for a time depth relationship file, which is this one here. So we open that. These can be given the name of LAS or TDA, and you can see this is the range of data in there. So we just hit OK because we're going to set those as defaults. I only want to take from 10,500. And then I want the sample rate to be 0.5 of a foot, and we just load that in, and we can select the curves that we wish to load. In this case I'm just going to take the azimuthal curve, but you can take any of the other curves that are in this file that are important to you. Under each name it's giving you the description of each curve, and we just hit OK and it's loaded those two curves here. So the first thing that we want to address is the tadpole plot. So if we go and look at the tadpole plot, we need to select this log as the inclination and this log as the azimuth. Now obviously nothing's appearing here because we haven't interpolated the data. So let's go and do that first. So let's go and interpolate the azimuth. And this is an angular type. Logscope allows you to interpolate linear, logarithmic, down, up for step functions, and angle. So we want to say angle, and we just hit OK. And all of a sudden we start to see some of the data. So let's go and do the other half of the azimuthal curve. Now, this is inclination, so this is going to be linear. Azimuth wraps around at 360 degrees, but linear is 0 to 90 and does not wrap around. So all of a sudden we've got the tadpole azimuth data there. Now, this tadpole is plotted on a range of 0 to 90 degrees. So, as you can see, this well, or this section, is pretty much horizontal. So we have a lot of 0 values here. So what we can do is we can go to functions and set them to missing. And I'm going to select all the logs. I can do this, select, I don't want to do that, and I don't want to do the time, but I do want to do the depth. And we're going to set the zeros to missing. So those have all been set to missing. So we need to interpolate them now. So I'm going to do the interpolation of the RPM and the flow as a step-up function. And I find the flow, which is here. So those two are going to be interpolated as a step function. And now we have the full curves. These other curves, let's interpolate them, and let's interpolate them linear. The ROP could be interpolated as a step function, but let's just do these as a linear. So we want SPP, and somewhere down here we will have wait on bit and hook load. And those are the ones that we're going to interpolate linearly. So that's done. And the next step is we really want to smooth these curves. So what we can do is we can go and hit the smoothing button, and we can smooth the ROP, the SPP, the torque, the hook load, and the wait on bit. I'm going to use a 5-foot window size, and you can preserve missing if you wish. I'm not going to do that. I'm just going to use a Gaussian filter. And I do that, and you can see now that all these curves have been smoothed, and the plot shows you what's happening in the well over this particular interval. Now the next thing that can be done is I can take this, I can drag this plot here, I can drag that plot there, and I can do a deviation plot. So we're going to set up the settings, and we're going to make the whole azimuth this, and the deviation azimuth this. And we're going to leave the scale at 1:200 ending feet. And voila, there we have the well with the hook load, weight on bit, and ROP plotted horizontally in the well. Thank you very much.